Hello everyone and welcome back to the AWS Solution Architect Associate series. Today we reach the final topic of the domain 4, that is design cost optimized data architectures, and this is also the last video of this entire certification series. Network design has a major impact on AWS architecture cost, whether it's a NAT gateway charges, data transfer cost, VPC endpoints, load balancing choices, or the connectivity models like VPN and the direct connect. In this session, we will explore how to optimize the network costs while maintaining the performance, security, and reliability. Let's dive into the designing highly efficient and cost-effective network architectures on AWS. To design cost-optimized network architectures, the first step is visibility. Using cost allocation tags, you can track which workloads or environments generate the most network-related spends, including NAT gateway, data transfer, and VPC endpoints. In multi-account environments, using AWS organizations, you can centralize the billing and get a clear picture of network usage across different accounts. This visibility helps you identify the patterns such as heavy cross AZ traffic, inefficient routing, or the expensive NAT gateway usage so you can optimize more effectively. AWS provides strong cost management tools to understand and optimize the network spend. AWS Cost Explorer helps you analyze the data transfer charges, NAT gateway usage, inter-AZ traffic patterns, and load balancer data processing cost. AWS Budgets lets you set the alerts if network charges exceed the expected thresholds. For deep visibility, the cost and usage report gives you the line item details like per service and per resource network cost. Together, these tools ensures that you can monitor the optimize your network cost in a structured data-driven manner. When optimizing the network cost, it's critical to understand what actually drives the charges. NAT gateway charge per GB processed, which can quickly add up when private subnets rely heavily on the external traffic. Cross AZ data transfer is another hidden cost. Every GB that flows between AZ is billed. Inter-region traffic is even more expensive and must be minimized whenever possible. Finally, the load balancer also incurs the data processing fees. By knowing exactly which patterns contribute to the cost, you can adjust architecture and routing to minimize unnecessary data movement. NAT gateways are often one of the biggest contributors to the network cost. A key design decision is whether to deploy a single shared NAT gateway or per AZ. A single NAT gateway is cheaper, but cross-AZ traffic incurs data transfer charges. On the other hand, one NAT gateway per AZ eliminates the cross-AZ charges but increases the base NAT cost. For a very small workloads, a NAT instance may be more cost effective, but the best long-term strategy is reducing the NAT usage by entirely using VPC endpoints so traffic to the AWS services stays inside AWS network without going through NAT at all. VPC endpoints are one of the most effective tools for reducing the network cost. Gateway endpoints for S3 and DynamoDB are free to use and eliminate the NAT gateway charges entirely for these services. Interface endpoints, powered by the private link, allows you to private connectivity for many AWS services without going over the internet. While interface endpoints have an hourly cost, they can significantly reduce the NAT charges for high volume workloads. Using the right mix of VPC endpoints results in predictable cost and improved security since traffic never leaves the AWS network. Routing design directly impacts the cost. For example, if your application isn't AZ aware, traffic may frequently travel between availability zones, resulting in ongoing cross AZ data transfer charges. By designing the components such as compute, storage, and database within the same AZ, wherever practical, you reduce the cost and improve the latency. Avoid routing traffic to the public internet unnecessarily and ensure that the traffic paths intentionally minimize the paid transfers. Localizing compute and data within the same AZ is one of the simplest, most effective cost optimization tactics. When connecting on-premise systems to AWS, choosing the right connectivity option is essential. VPC connections are low cost and easy to set up but comes with internet-based performance and potential variability. AWS Direct Connect provides highly reliable, low latency connections and may offer better long-term cost efficiency for large consistent data flows. The correct decision depends on traffic patterns, bandwidth needs, and compliance requirements. Proper bandwidth selection, whether a single VPN or the multi-high tier direct connect links, helps you control the cost while maintaining necessary performance. Network topology also affects the cost. Transit Gateway offers scalable hub and spoke connectivity, but it has high per GB data processing cost compared to VPC peering. For simple point-to-point communication, VPC peering may be a more cost-effective choice. Many enterprises uses the centralized shared VPC for DNS authentication, logging, and security tools, reducing the duplication and cost across multiple VPCs. Thoughtful topology design ensures the scalability, connectivity without unnecessary expenditure. Content delivery networks like Amazon CloudFront dramatically reduce the network cost by caching the content at edge locations. This lowers the data transfer cost from your origin servers, minimizes the load on compute or the storage layers, and improves the performance for users worldwide. Instead of paying for data transfer out from the EC2 or S3, CloudFront's global caching helps you deliver the content more cost effectively. For workloads with global traffic or the media delivery, CloudFront plays an essential role in optimizing both the latency and the cost. Designing a cost optimized network architecture involves combining several best practices: reducing NAT gateway usage, using VPC endpoints, designing AZ aware routing, selecting the right connectivity option, and building efficient network topologies. Each of these decisions contribute to lowering network charges without compromising performance or the security. The goal as an AWS solution architect is to balance cost, reliability, and functionality, ensuring every workload is both the efficient and sustainable. So to summarize, in this final session, we explored how to design the cost optimized network architectures using AWS best practices. We looked at network cost drivers, NAT gateway optimization, VPC endpoints, routing patterns, connectivity options, and network topologies that reduce the spend while maintaining the performance. And with that, we have completed the entire AWS Solution Architect Associate series. From Domain 1 through Domain 4, we have covered every concept you need for this exam, along with the real world architecture patterns to help you excel as a cloud architect. Thank you so much for following along this journey. If this series helped you, don't forget to like, subscribe, and share. And I wish you all the best in your AWS certification journey. Thank you.